Anna McCabe, a junior in AP Chemistry with Mr. Seguin, and today I will be discussing typical molar conversions that are commonly used in chemistry. When we begin to discuss the conversions, you have to know the basics of moles. There are many different types of units used for molar conversions, some of the most common being particles, moles, molar mass, and Avogadro's number. You may also see atoms, ions, formula units, or molecules. In order to simplify the different types of conversions, there's a table that is very useful if you know the correct way to use it. The table shows how the different conversions are related to one another. At the top, you have particles of a given related to moles by Avogadro's number. At the bottom, you have volume of a given related to moles by 22.4 liters per mole. And on the left, you have mass of a given related to moles by the molar mass. When we do molar conversions, the easiest way to go about solving the problem is to use dimensional analysis, a way of setting up problems where we have to cancel units. You should also be familiar with standard conditions. The standard temperature is 0.00 degrees Celsius, and the standard pressure is 1 atmospheric pressure. You have to take this into consideration when doing these conversions. First type of molar conversions I will be discussing is mass and mole conversions. There are two steps in this type of conversion. Step 1, determine the molar mass of the compound, which you find on the periodic table. And step 2, you can solve the problem using dimensional analysis, either mole to grams or grams to mole. This conversion takes you from the number of moles of a substance to the total weight of that substance, or vice versa. An example of a mass to mole conversion is when we say we have 20.0 grams of calcium, and for every 1 mole of calcium, we know that there's 40.08 grams. That's the molar mass from the periodic table, so we know that we'll have 0.499 grams of calcium. For a practice problem, try a mass of 2.5 moles of K2CrO4 and pause the video. The first step in solving this practice problem is finding the molar mass of K2CrO4. You know you'll have 2 Ks, 1 Cr, and 4 Os. Find the molar mass of each atom on the periodic table and add them all together. So you should end up with a total of 194.2 grams per mole. When you have that, you can take your 2.50 moles of K2CrO4 and multiply it by the molar mass. So multiply it by 194.2 grams for every 1 mole. Cancel out the moles, and you should be left with 486 grams of K2CrO4. This is a very basic moles to mass conversion. How many moles are there in 18.2 grams of oxygen? Pause the video and try for yourself. As you can see here, I found the molar mass of oxygen on the periodic table, which is 16.0 grams, and I multiplied 18.2 times 1 over 16.0 to get your total of 1.14 moles of oxygen. The second type of molar conversion I will be talking about is particle and mole conversion. As I said before, there are many different terms for particles, such as atoms, ions, formula units, abbreviated FUs, or molecules. This process also utilizes dimensional analysis. Another important detail of mole-particle conversion is Avogadro's number, 6.02 times 10 to the 23rd particles per mole of a substance. This number is based on Avogadro's hypothesis, which states that at the same temperature and pressure, equal volumes of gases contain the same number of particles. Or in simpler terms, a mole of any substance contains 6.02 times 10 to the 23rd particles. These conversions help you with converting between particles and moles. This type of conversion also has 2 basic steps, just like mass and mole conversions. Step 1 is to know how many particles are in a mole of a substance and what type of particle you are solving for. Step 2, you must use dimensional analysis to solve the problem, either going from particles to mole or moles to particle. When looking at an example of this type of problem, you can see I started with 2.4 times 10 to the 24th atoms of argon. And I know that in 1 mole of argon, there's 6.02 times 10 to the 23rd atoms of argon. So I know that I have 4.0 moles of argon. I canceled out my atoms. For practice problems, try how many moles are in 1.2 times 10 to the 25th atoms of phosphorus and how many atoms are in 0.750 moles of zinc. Pause the video and try. Here are the solved practice problems. So in the practice problem number 1, I know I started with 1.20 times 10 to the 25th atoms of phosphorus. And I know that in 1 mole of phosphorus, there's 6.02 times 10 to the 23rd atoms. So I multiplied 1.20 times 10 to the 25th by 1 over 6.02 times 10 to the 23rd to get a total of 19.9 moles of phosphorus. In the second practice problem, I started with 0.750 moles of zinc, and I know that in 1 mole of zinc, there's 6.02 times 10 to the 23rd atoms, so I have to multiply 0.750 moles by 6.02 times 10 to the 23rd atoms to get the moles to cancel out, so I end up with 4.52 times 10 to the 23rd atoms of zinc. I have to make sure that I either cancel out atoms or moles depending on what the problem is asking me for. The final type of molar conversion that I will be discussing is volume and gases of moles. This type of conversion is very similar to the 2 other types that I have previously discussed, but there's one small detail that makes it stand out: molar volume. Molar volume is the volume occupied by 1 mole of gas under standard conditions. This type of conversion has a set conversion factor of 22.4 liters per mole. You have to be very careful with your units here and make sure the problem specifies you are under standard condition, so 0 degrees Celsius and 1 atmospheric pressure. The steps to solving this problem are very similar. Step 1, you must determine how much volume 1 mole of any gas occupies under standard conditions. On step 2, you must solve using dimensional analysis, so going from moles to liters or liters to moles. For the example problem, you can see that I started with 7.3 moles of oxygen gas. I know that in 1 mole of oxygen gas, there's 22.4 liters, so I multiplied 7.3 moles by 22.4 liters per mole in order to cancel out the moles and end up with 163.5 liters. For practice problems, try converting 261.5 liters of CO2 gas to moles and convert 27 moles of F2 gas to liters. Assume that both of these are under standard temperature and pressure. Try these now and pause the video. When looking at the solved practice problems, you can see that I started with 261.5 liters of CO2 gas. I know that in 1 mole of CO2 gas, there's 22.4 liters. So in order to cancel out the liters to end up with moles, I have to multiply 261.5 by 1 over 22.4 to get 11.7 moles of CO2 gas. When I convert 27 moles of F2 gas to liters, I know I start with 27 moles of F2 gas, and I know that in 1 mole of F2 gas, there's 22.4 liters. So I multiply 27 by 22.4 in order to cancel out the moles and end up with 604.8 liters of F2 gas.